Hello friends, we are continuing with the next video, that is ARMA model, and this is part of the 20 videos on data science. As you can see on the screen on the right hand side, actually you see this is temperature variation from a heater, that is in blue, that is the data set which we have created, and the red ones are the projection or forecast. It automatically understands the behavior of the trend and is able to forecast. How is it possible using ARMA model? That is what we are going to discuss today. Now, ARMA stands for auto-regressive moving average. It's a time series model. Time series we discussed earlier in the videos is a timestamp data of equal times, and it's a one single data, and we will be now using AR and MA combined to make ARMA. AR stands for auto-regressive model, which we covered in the last videos, and then moving average, that we will be discussing now, and the combination is called ARMA. Now, as I said, ARMA was discussed in video 3 of the series. Now, it was AR is called auto-regressive, and this component captures long-term trends in data by considering the relationship between the current value and the past values. In this way, it assumes that the future behavior of the variable is influenced by its own historical behavior. Now, again, moving average, the second part of it, that is moving average, MA, here the errors are considered. Errors are all considered for forecasting. And this component captures short-term fluctuations in the data that may not follow a clear pattern. That is where moving average comes in picture. Now, it means that if there is a sudden increase or decrease in the time series, MA component helps the model to adjust accordingly to these changes. Now, as you can see on the screen, how a moving average model works. And please remember, moving average smoothing of the video 1 is different from moving average model. We are talking about a model. Okay, that was just a smoothing. Now, here, if you say next prediction MA in bracket 1, can be expressed as YT is equal to mean. This is mean plus C1 multiplied by the error. This is the error of the past one value plus C2. So, through this example, we can demonstrate, we can understand the moving average, how it works. See, let's say you want to predict the number of workers required by a company every next day. Now, it depends on the work in the company. This is a very small company, let's say. So, in every day, the number of requirements vary, and they hire in daily wages, let's say. So, now, the first day, so there is no prediction done. So, it's like that. And the actual number of workers were required were 4. And so the second day, the predicted prediction, we simply write 4 itself here to start with. After that, they found that the actual number of workers required were 10. That means here there is an error of -6 for -10. Now how do we forecast the next ones? Like, how do we forecast this particular value in this cell? So the equation is the YT is equal to the mean plus C1 multiplied by error time. Let's say C1 is -0.5. So now you see that 4, that is the mean, the 4 is the mean, and plus -0.5 is the constant, that is C1, multiplied by the earlier error, that is -6. So it forecast at 7, but the required workers were again 14. So here there is an error, -7. Now next forecast you have to do using moving average method, that is the mean plus C1 is a constant multiplied by the previous error minus 7, that is equal to 7.5. So what was the actual number of workers required? 9. So error is now minus 1.5. So see that error is getting reduced. And now taking, the whole point is taking the error, helping you to keep up with the original trend. See the original trend and see the error trend, and which are going in the similar fashion. And so this is the first model in which the previous error is considered to predict the next value. And now the auto-regressive moving average model, this is ARMA, it has got the biggest advantage, that is that these models are relatively very simple. They only require very small data set to make a prediction. They are highly accurate and is very good for short forecasts, and they work on data without trend. That is the advantage. And where are the applications of ARMA? Imagine predicting tomorrow's temperature. The AR component would consider how the temperature has been changing over the past several days to predict what it might be tomorrow. And also second example, let's say tracking monthly sales of a product, and unexpected sales in sales, maybe due to December sale or whatever, actually due to a special promotion or a sudden drop because of an unforeseen event, could be captured by the MA component. Now, usually the ARMA model is written as part of an ARMA model. And what is ARMA? It will be discussed in the next video, but for the time being, I part we keep it silent. AR and MA. So you can pass P, D, Q, and you accordingly you can make this particular thing working for ARMA. So where the P is the order of the auto-regressive component, and D is the concept of ARMA, and hence equal to 0. If you make I part, actually the middle part I made it 0, that means it automatically becomes ARMA. And Q is the order of the moving average component. So I said AR and MA is combined. AR is having a P and MA is having a Q. Now, how do you test this ARMA model using a Python program? As we already discussed earlier also in the coming videos, pandas and matplotlib are two libraries which we can't avoid. And state model is also being used for testing this. Now the data set actually, which we have 300 points of temperature, which we put on a heater and put it off. Suddenly the drop in the heater temperature has been captured in a CSV file, and that is what, if you exactly see what is inside this will be a dropping temperature curve. And now what you're doing is you are having a loop which goes from 1 to 5, and AR order I am changing from 1 to 5, and MA order we have fixed it. Actually, we do not want to play with both the AR and MA, and we are only varying AR. So you can see that when you pass these things into the ARMA order, and when we call the ARMA model, and the data set is being passed. So as you can see, the data set is nothing but the blue line here. You can see that that's the data set which was going inside, and we are going to predict the red part of it. So now you can see in the program the ARMA model is now created, and here there are 4 arguments. Trend is equal to n, like here trend is equal to n. What it means is, like, it does not include a trend component. It assumes that the data set does not exhibit any systematic trend over time, whereas trend is equal to C includes a constant time in the model representing a constant trend over time, and trend is equal to T includes a linear trend in the model assuming a linear increase or decrease over time, and trend is equal to CT. This includes both constant and a linear trend in the model. So in our case we have taken trend is equal to n. Now we are fitting the model, and you are getting the prediction from 300 to 400. Now Before 300 it was a real data, now 300 to 400 is a forecast. Now it's simply plotting the output, whatever we are getting. You can see that the blue lines were the real data set, and this is what is the projection when AR order is equal to 1, MA order is equal to 3. It doesn't look good at all. It's not a good job it has not done. Now I increase the AR order, is able to somewhat understand the behavior trend actually, is able to forecast. Now I increased further AR order 3, even better. 4, if you closely watch, even better, it is becoming like all kind of the patterns of the data set is being forecasted quite well. Now AR is equal to 5, it is able to forecast even better. So summary is, the ARMA model provides a powerful framework for analyzing and forecasting time series data. And also remember, the advantage of ARMA model is the ability to adapt to different patterns in the data, providing a balance between capturing historical trends and reacting to recent changes. Now, the flexibility and interpretability of the ARMA model make it suitable for various applications from finance to climate science. And by combining AR and MA components, the model captures both long-term trends and short-term fluctuations, offering valuable insights of the underlying dynamics of the data. You will find many more videos of mine. At the same time, the program is given in the description, and we are now going to show a demo of the program, whatever we were showing in the video. Now if I run this, you can see that this is the exact program where see, it is going to give you the results. You can see in the program the AR order was I and MA order was 3, and now you will see for different values of I how it different values of I, that is the AR order, how the output is going to come. You can see now the screen has come now. For AR is equal to 1 and MA is equal to 3, it doesn't look good at all. It's not able to forecast. Now when how AR order is equal to 2, it is still able to intelligently bring back a bit, not exactly. And now you see AR is equal to 3 is still better. You see, is able to forecast quite better, predict better. And then AR is equal to 4, even better. And now AR is equal to 5 is almost following the exact trend. So that is how it is, and see you in the next videos. Thank you.